Okay, so here is another video for class 5. We were talking about the ideal gas law. And I have these little apparati, because I have two of them. I have this little guy right here, and I have this little guy, and I thought they looked really cool, but this is when I was doing solid mechanics stuff, and I talked to the department chair, said, hey, check out these would be kind of cool. Next thing I knew, I think he mistakenly thought that I was asking for them because I bought them, but I'm glad he did. All right, so I'm going to turn the temperature gauge on, and I'm going to close the valve right here. Take a look at the units right here. This starts out at 65. Whoops. Let me open up the valve again. I'm going to try to get as accurate as I can. Let's see. I'm going to get right up, right where the edge of the plunger. He's right there. You can see our temperature is 24.1. And this gauge, we're going to use, I think I'm going to go ahead and use PSI and convert it because it has a better resolution than the inner one, which is Pascal, right? So 10 to the 5th Pascal is what the red ones are doing right there. So it's hovering right there about 15. Right, so this is this gauge turns out to be an absolute gauge. It says actual pressure right here. This is a 65 milliliter, and of course this degree C. So here is the Excel sheet that I used when I recorded the data myself. I should probably show you how I did this, but that would make the video much longer. I started out with an assumed density. And then you go, here's the mass right here, right? I'm starting out with 65 milliliters. So that's the total mass I'm saying that's inside the cylinder right now, inside this cylinder. And so I'm going to record this information right here. It's going to go ahead and give this back as a specific volume. The pressure is going to be converted into Pascal, and then the temperature is going to be converted there, and we're going to find the R, right? We don't expect to get the right number. We're going to get a whole bunch of different numbers depending on which way we go, but it's going to be an interesting thing, and I have it so we could plot out like the pressure versus the specific volume. I did it for the black machine and the gray machine, but we're not going to have enough time in this video. I've already spent like 3 minutes explaining it. So let's take some data. This is closed, so our first data is simply going to be 15 here and 24.1. Right, so we already have a data point plotted up. Interesting. Okay, and now let's go up a little bit. Let's go up by tens. I can't quite see that. I think that's about it. That looks pretty good to me. Temperature didn't go up. We went up by, these are increments of 1. So that looks like 16. So that's not an exciting result, and the temperature didn't go up. 24.1. You start to see, well, it's not as sensitive to temperature. And also, by the way, this thing is cooling down as we, it's not insulated. So there's a little bit of expected losses going on in there in terms of the process. And that looks pretty good to me. Still not a temperature change, but it looks to me, if we look carefully at there, that's 17.5. That's about as best we're going to do. 17.5. And our 24.1. We could jump ahead if we wanted to, or we could be methodical and make this a longer video. Still no temperature change. Interesting. But it does look like we went up to 19. You could even, if you wanted to be careful, say 19 in a little bit. Let's just put in 19. And 24.1. So far, this is like an isothermal process. You notice. I have to take my glasses off to be able to see this. I'm feeling some pretty good resistance to putting down there. Still no temperature change, but we are now up to 21. 21, boom, and 24.1, 24.1. Go to 40. Let's see, I gotta look at this thing because I'm parallax error. There we go. Oh, 24.2, we went up. Oh, now down at 24.1. What was our pressure? That's more important. That looks like 24 to me. So 24, and I saw 24.2, so I'm gonna stick it in there, even though it's jumped back down. 24.1. Skip to 35. $24.2 again, and now we are at 25, 26, 20, 27.5. Right, it's right in there. It's like 20. There's 26. There's 27. 27.5. I'm gonna go 27.5. 27.5, and the temperature went to 24.2. You really wanted to. Down to 30 now. Still at 24.2, and now we're up at 30. Ooh, see, now this is what parallax error is right there, right? Is that at 32? Is it at 31? I'm gonna call it 32. We're calling it 32. This used to be my job, by the way. Just go on board ships, read gauges, collect data, come back home, try to interpret the data. Look at that, got a little glow coming off of that. A little glare, glare. All right. Parallax error is when you look at a gauge like from that direction as opposed to that direction, or from this direction right there, and you can kind of like mess with what the answer is. Sometimes there's a mirror actually behind the gauge needle, so you can line up the gauge with its reflection, with the needle with its reflection, so you don't make that mistake. So 35, 36, oof, is that 37.5? I'm gonna think 37.5. 37.5. And also, we still haven't budged from 24.2. Interesting. Look at this little wavy line going on right there. Aren't you cute? All right, so let's go one more up, 20. And it goes, explodes. Yeah, you would expect the temperature would start coming up. Right about there. All right, what do we have? That looks like that looks like 45. 41, 42, 43, 45. 45 and 24.3. Finally. Now, I just take a look at this process right here. All right, so I have some. I should probably get rid of the ones that came over there. All right, so we're just gonna get rid of so that they don't distract us. This is the stuff from the gray. Is it over here? Yeah. I'm gonna get rid of the gray. All right, so this is like because I did it twice. I did it over here not gray, for the black machine. Now I want to go back downwards now that I'm right here and see what happens. It's sort of lost. You can see that the gas constant, the known gas constant should be what? 287. So check us out. That's not quite that bad, right? Here's a 286 right in there. Here's a 288. So we kind of are in that line right there. What I could do is I could plot 287 right in here. See if I go from 0 to 70 for 287, I could just click right in here and select data. I'll add, and my X will be from here to here. Whoops, stop. My X, get out of the way, go away. My X will be from here to here, and my Y will be from here to here. And I could plot that, and it's data points right now, but we'll format the series and go with a line, a solid line across there, right? So, and also, let me make that to 70 because that's all we had anyway. Okay, so you can see here's the data that we collected. Interesting. Let's go backwards. We're at 11 minutes, but this is sort of interesting. But I really like this process. Check out that process. I've also put on top of this, by the way, a power curve, because we would expect a polytropic process. We'll talk about that on a PV diagram. And so what we can do, we can add on display the equation right here. So a lot of times we're going to be looking for the exponent in this process, right? It's going to be pressure is equal to some number times volume raised to this exponent right here. So this is sort of an interesting thing to check out. We have to make sure that all of our units base out, but it's just really this sort of the shape of this process looks like it lends itself pretty well. In fact, actually, you can actually have a measure. I should have put this on there. We see the display equation on there. There's the display of the equation. There's also the R value, an R squared value. And the closer that gets to 1, it kind of gives a measure of how close this data fits into what you're looking at. It's an important thing. So let's go backwards right here. We can go downwards. Has the temperature dropped? The temperature did drop a little bit. We will ignore that, and we will bring this backwards. Lefty-loosey, and lefty-loosey, yeah. Go back to, and spoiler alert, I think they're different because this isn't pure air. It has water in it. So anyway, here you go. Here's at 25, and we are now at, well, it looks like 37.5. So that's making a liar out of me because I think we just went back 37.5. And we also, the temperature is now 24.1. It has stabilized, come back down. I'm kind of surprised at how well that worked. Let's see. Let's get back to exactly 30 if we can. 23.9, interesting. 23.9, and we went to 32. Oh, look at that. It didn't look like it. Doesn't look like it's. It didn't change anything, but we did have. Did I always say 39? And now it's to 24. I can't remember. I'll bring it back. Okay. And let's come back some more. And there's a good chance we would want to run this a bunch of times. That looks like a 28 to me, and 23.9. Still 23.9, but now we have 25, it looks like. 25 and 23.9, boom. Ooh, that was quite the outlier right up there. See, look at that guy jump up there. Right up there, wow. And the temperature changed too. Interesting. 23.9 again. And now we're at, I want to go 22.5 or 22.25. Or are we getting to exact? Not 25, I mean 20. Yeah, 22 point, yeah. What do you think? 22.25. Now I'm talking to myself. At 23.9. And then let's go up here. Oh boy, that's just a little over 20. And I still showing, well, actually, I just went up to 24.1. Interesting. And it's getting very loose right now. 55 is it there? So we get, looks like 19. And I have 24.1 again. And then at 24 degrees, and it looks like it's at just over 17. We'll put it at 17 and our 24.1. And lastly, this should go right back, right? I wonder if any leaked past. No, it's still 16. It's interesting, right? So 16 and 24.1. So some of our conclusions, the temperature didn't really change a whole lot. It does look like we got better data on the way down than we did on the way up. There's my oranges on the way up. You can see that does a pretty look at it. It still has sort of a polytropic kind of process right there. It still has it still has a trending. It's kind of interesting. So what we could do sometimes, very useful, is I like to copy this over and push it over here, and then I can put in, and I could write in, oh, I can't figure out where it goes. Chart area? No. Trying to see the thing. Where is it? Oh. Gonna make a liar out of me. I can't remember now. Where it goes. So you can paste it. Change style. Save template. Save. Move chart. Move chart to new sheet. There you go. So now we can mess around with it. So the other old chart, because I did a copy and paste, is still right there. So I can make this a little bigger, and I can analyze it and see it a little bit more without zooming. Yeah, so maybe I want to put this over to the side over here, and I'll go back over this trend line. By the way, let me show you how to make that trend line. Here, I'll get rid of the trend lines. You can see here's the data, and you can click on this and go right click and add trend line. And it defaults to a linear one. You can put an exponential in there. That's not very good. Go to logarithmic. That's not bad. You could do a polynomial. And you could, by the way, you could increase the polynomials until they get weird. No, okay. No, it did. This is just a quadratic right in there. But you can see that the power really kind of does a better job overall, in my opinion. And you can kind of see display the equation on the screen, if you can get that over. Sometimes it's not big enough, so you can increase the font. And then you can also, while you're clicking on that, you can display what the R is. And then you can try it again right here. Right click on the blue dots. I didn't mean to do that. Right click on the blue dots and add trend line. There you go. You go linear, but let's just go to the power. And you can see display equation. Of course, that's too small. And make the thing bigger. Put the R squared onto the thing. Yeah, they're about pretty much the same amount of goodness. I'm trying to think of the right word. R's. R is a confidence. Is that confidence? I don't know. What is R? Yeah, I'm trying to remember the name of the R. Anyway, the R squared term. You get a better idea of how this was behaving when it was going through the states and going from one state to another, and the overall process. But that's enough for a video, and it was an interesting type of thing, right? It was I call this the template. It's interesting to see that we're getting in the range of the R that we would expect from here, right? We're expecting to get 287, and we are getting somewhere in that range right there. We're crossing it. We're getting really close. So I think it's pretty neat kind of test, and maybe makes it seem like a little bit more real instead of just a bunch of numbers. That's it.